Welcome to the deep dive. We live in a world just saturated with data, right? Raw data, often messy data. Think about the sounds in your headphones, or maybe even the tiny electrical signals from your own body. How do we actually make sense of it all? How do we turn all that noise into something clear? Or, take these seemingly random signals and find vital insights. Well, today we're really getting into the fascinating world of signal processing. And specifically, we're unpacking a kind of unsung hero that makes a lot of it possible, MATLAB. Yeah, our insights for this deep dive, they come straight from an expert analysis called MATLAB, Essential Tools for Signal Processing. So our mission here is to really understand why MATLAB has become such a go-to tool for signal processing pros. We want to look at the specific capabilities it offers, the techniques, and maybe most importantly, how all that power turns into these incredible real-world uses. Things that affect your phone calls, advanced medical diagnostics, even, yes, your favorite music. We're aiming to show you just how fundamental this tech is.
Yeah, and what's really striking is just how pervasive signal processing is. It pops up in fields you might not even connect immediately. Telecommunications, obviously, but also audio engineering, biomedical stuff, sophisticated control systems. It's really the silent workhorse behind so much modern tech. And like our source points out, MATLAB really does stand out. It's one of the most powerful software environments for doing everything from, basic signal analysis to really complex transforms and visualizing it all.
Okay, so given that huge scope, why MATLAB then? What is it about this particular environment? What makes it the choice for something so intricate, so diverse? What's its edge?
Well, the core reason, I think, is its comprehensive integrated suite. That's the key. MATLAB gives you this incredibly rich set of built-in functions, right? Plus highly specialized toolboxes and really robust ways to visualize data all in one place. This means engineers, researchers, even students can tackle complex signals effectively, and they don't get totally bogged down writing tons of low-level code from scratch. It's designed to be intuitive enough for maybe a basic Fourier transform, but it's also powerful enough for really advanced spectral analysis. It's kind of an end-to-end solution.
Right, so it's not just about power, it's also about reducing the friction, getting things done more easily. That sounds like a huge advantage. But you mentioned toolboxes. I get the feeling that's where MATLAB really sets itself apart, offers those specialized capabilities. Can you dive into some of those specific tool sets, the ones that make such a difference?
Oh, absolutely. The source definitely highlights that comprehensive suite as a big differentiator. It points to several key toolboxes that are pretty foundational for anyone working in this field. The signal processing toolbox, for example. That's really the cornerstone. It provides just a huge array of functions for essential tasks. Things like filtering, removing noise, enhancing certain features, resampling signals, doing spectrum analysis. It's packed. Then, for people actually building the systems, there's the DSP System toolbox. That one's specifically designed for, designing, simulating, and even implementing digital signal processing systems.
Okay, so designing the actual hardware or the software systems themselves, not just analyzing signals that already exist. That's a pretty crucial difference, right? Letting you build from the ground up.
Exactly. And think about signals where the frequency content changes over time, like speech or music. For those, the Wavelet toolbox is invaluable. It lets you perform time-frequency analysis, really dig into how components evolve. And speaking of audio, there's actually an audio toolbox too, specifically for speech, music, acoustic signal analysis. It offers functions for everything from basic playback to advanced sound manipulation. And to round it out for people who maybe prefer a more visual way of working, the Filter Design and Analysis app is this fantastic GUI-based tool. It lets you design and analyze filters without writing a single line of code.
Wow, okay, that's a huge plus for accessibility, isn't it? Makes something like complex filter design much more intuitive, even if you're not primarily a coder. So, okay, you've got these powerful tools. What are some of the key techniques then, the things you actually do within MATLAB to process signals and pull out the meaning?
Yeah, good question. If you connect it back to the big picture, it's really about turning that raw, often kind of chaotic data into something useful, actionable insights. One of the most common techniques is filtering. Think of it like a really smart sieve for your data, a low-pass filter. It lets through only the slow, sort of foundational changes. Imagine like filtering static from an old radio broadcast, just hearing the music underneath. A high-pass filter catches only the rapid changes, maybe detecting a sudden critical spike in a medical signal. And a bandpass lets you isolate a specific range, like pulling out just a human voice from background noise. It's about cleaning or isolating parts of your signal very precisely.
Okay, that really clarifies filtering in practice. What about Fourier analysis? I know that's like a fundamental concept, but what's the aha moment there for someone trying to grasp its power?
Great question. Imagine trying to figure out a complex piece of music just by looking at this long, squiggly sound wave on a screen. Pretty much impossible, right? Fourier analysis is kind of the magic trick that breaks that wave down into its individual notes and its frequencies. It reveals the composition of the signal. It's how we go from just a jumbled mess to understanding the precise components that give a signal its character. You uncover patterns you just can't see looking at the signal over time alone. And building on that, there's spectral estimation. That lets you measure how power is spread across different frequencies, helps characterize the signal. Then for signals where frequency isn't constant, like we mentioned, time frequency analysis lets you study how that content shifts over time, often visualized with spectrograms, wavelets. Really powerful stuff. And in dynamic situations, adaptive filtering is key. These are filters that actually learn. They adjust their own parameters in real time based on changing signal conditions. Think noise-canceling headphones adapting to the room you're in.
Right, that adaptive part is fascinating. Which brings us to a crucial point. All this technical wizardry, the toolboxes, these techniques, how does it actually translate? Where are we seeing MATLAB's signal processing capabilities making a difference in our lives?
Oh, the applications are surprisingly pervasive, really everywhere. In telecommunications, it's absolutely crucial. Things like noise reduction in your phone calls, right, and ensuring clear conversations. It also handles modulation, that's basically encoding information onto a carrier signal so it transmits efficiently.
Yeah.
And demodulation, the reverse process, decoding it at the other end. That's fundamentally how your mobile device sends and receives data so seamlessly.
Okay, yeah, that makes the telecom part very clear. What about the medical field? That feels like an area where precision is just paramount. How's MATLAB used there? Is it about signal clarity or is it something more?
You're absolutely right. Precision is everything there. In the medical field, MATLAB gets used extensively for analyzing signals from things like ECGs, that's electrocardiograms measuring heart activity, and EEGs for brain waves, even ultrasound signals for imaging. This lets doctors and medical pros interpret vital diagnostic info from those, complex squiggly lines you see on monitors, which leads to more accurate diagnoses, better patient care. It's critical. For audio processing, beyond just listening, it enables really sophisticated tasks, things like equalization to shape sound, echo cancellation to clean up recordings, compression for efficient storage and transmission. I mean, think about how much music you can fit on your phone. That relies on this.
Right, so it's not just making music sound good, but also making sure we can actually get it and store it efficiently. And what about in, say, industrial settings? Where does it impact things there?
In industrial systems, signal processing is vital for things like fault detection and vibration analysis in machinery. By analyzing those signals, the vibrations, the sounds engineers can often predict when a piece of equipment might fail. That prevents costly breakdowns, increases safety. It's a big deal for operational efficiency. The source really drives home that using MATLAB for this stuff doesn't just speed up the computation and the analysis. It also significantly improves the accuracy and the efficiency across the board. It really empowers innovators in all these different fields.
So pulling all these threads together then, what's the ultimate takeaway here? It seems like at its core, MATLAB, with these powerful toolboxes, these techniques, the visualization, it really empowers professionals, researchers, empowers them to tackle even the most complex signal challenges with confidence. It's about taking that raw abstract data and making it understandable, actionable, which speeds up discovery and just makes processes way more efficient and accurate in so many industries.
Exactly. And this really raises an important question for you, the listener, doesn't it? Just how pervasive, how fundamental is this signal processing, often aided by tools like MATLAB in the tech that surrounds you every single day? From the clarity of that phone call you just made to maybe a medical scan giving a precise diagnosis. So much of what we experience as just seamless technology relies on this invisible engineering, constantly shaping and refining the information that kind of defines our modern world. It's truly everywhere, even when you don't see it.
That is a powerful thought. Really makes you consider the incredible power hiding in these precise tools, shaping all this unseen information around us. Well, thank you for joining us on this deep dive. Keep exploring, keep asking questions, and keep deep diving into the fascinating world around you.